In this video, I will discuss few questions about subatomic particles, electrons, protons, and neutrons. Let's fill the following table regarding features of subatomic particles. Symbol of electron, proton, and neutron are E, P, and N respectively, and we can also write it in the complex form, indicating the charge on the top and relative mass on the bottom. Coulomb is the unit of electric charge. Electron minus 1.602 into 10 to the power minus 19 Coulomb plus 1.602 into 10 to the power minus 19 Coulomb, and for neutron the charge is 0. Relative charge is simply minus 1, plus 1 and 0. In mass, we should consider in which unit we have to write the answer. If the question tells us to write the answer in grams, we should be able to convert the value from kilogram to gram. Relative mass of electron is 1 over 1840 approximately, and relative mass of proton and neutron is 1. Electron is discovered by J.J. Thomson, proton by Ernest Rutherford, and neutron by James Chadwick. If the question tells us to write the answer in grams, the power of tens of the values will change. Now let's see how to convert a value in kilograms to grams. K in kilograms is a prefix that denotes 10 to the power 3. Therefore, we can substitute 10 to the power 3 instead of K and get the answer. When we simplify the powers of tens, which is minus 31 plus 3, we get the answer as minus 28. Finally, we get the answer as 9.107 into 10 to the power minus 28 grams. When writing the relative mass of a subatomic particle, we write it with respect to the mass of the proton. Therefore, the relative mass of proton with respect to the mass of proton is definitely 1. If we divide one proton into 1840 parts, the mass of electron is approximately equal to one such small part. If we consider the mass of a neutron and a mass of proton, we can see that there's a slight difference in the point values. Therefore, we can say that the relative mass of neutron is slightly greater than the relative mass of proton. Now let's move to the next question. State whether the following statements are true or false. First one, mass of a proton and neutron are equal. This statement is false. Let's briefly explain why this statement is false. Mass of neutron is slightly greater than mass of proton. That small extra mass is equal to mass of meson and positron. Second statement, the mass of a proton is negligible compared to mass of an electron. This statement is also false. Mass of proton is 1840 times greater than the mass of electron. Therefore, Mass of electron is negligible compared to mass of proton. The third statement is the atoms become neutral when they contain the same number of protons and neutrons. This statement is false. Proton is positively charged and electron is negatively charged. When the number of protons and number of electrons are equal, the atom becomes electrically neutral. Fourth one, only electrons involved in chemical reactions. This statement is true. In chemical reactions, an electron exchange takes place. Gaining, sharing, and liberating electrons is called a chemical reaction. Fifth statement, protons and neutrons rarely involve in chemical reactions. This statement is false. During chemical reactions, mass number or atomic number is not changed. Therefore, number of protons and neutrons are constant and they do not involve in chemical reactions. Sixth one, only protons and neutrons mainly contribute to the mass of an atom. This statement is true. Mass of electron is 1 over 1840 times the mass of proton. Therefore, the mass of electron is negligible and it is not considered as a contribution to the mass of atoms. Also, contribution of neutron for mass of atoms is greater. Seventh statement, when atoms liberate or gain electrons, these liberated or gained electrons directly affect the mass of an atom. This statement is false. As the mass of electron is negligible, gaining, sharing, or liberating electrons will not affect the mass of an atom. Eighth one, sometimes electrons act as a particle and sometimes as a wave. This statement is false. According to de Broglie's equation, electrons show wave and particle nature at the same time. Ninth statement, protons and neutrons are collectively known as nucleons. This statement is true.